In this video, we're going to be factoring out the greatest common factor. Before we get to the practice problems, let's do a quick review of a couple of concepts from the textbook. First of all, the greatest common factor, also known as GCF, of the terms in a polynomial has the following qualities. First of all, the numerical coefficient is the GCF of the numerical coefficients of the terms. Secondly, the variables represent the lowest power of the variables in the terms of the polynomial. In order to factor out the GCF, we need to determine what the GCF is and then write it. And just a quick note on this, if the polynomial in one variable is written in standard form and it has a negative first term, then we're going to be writing a negative GCF. Once we know what the GCF is, then we can divide each term of the original expression by the GCF and write the resulting polynomial in parentheses. So that's the process we're going to follow as we do these practice problems. Let's go ahead and look at the first practice problem. We want to take the expression 18x minus 30 and factor out the GCF. Let's do that now. The first step is to determine what the GCF is and write it down. So let's look at the numerical coefficients. We have 18 and negative 30. The GCF of those is 6. And because the first term in this polynomial is positive, we're going to write positive 6 in the GCF. Now let's analyze the variable. There's only one variable here, and that's the x in the first term. So we have x to the first power. The second term doesn't even have a variable. We could think of it as x to the 0 power, I suppose. But in any case, the lowest power of x would be 0, and when that happens, we don't actually put a variable in our GCF. So the GCF in this case is just 6. The next step is to divide each term of the polynomial by the GCF, which in this case is 6. So we're going to divide each of these terms by 6, and we're going to write the resulting terms in parentheses. So 18x divided by 6 gives us 3x, and negative 30 divided by 6 gives us negative 5, so we'll write minus 5 as the second term in the parentheses. And that's it. I'm done factoring out the GCF. The factored expression is 6 times parentheses 3x minus 5. Let's move on to the next practice problem. Our next polynomial is 8n to the fourth minus 36n cubed plus 4n squared. Let's go ahead and factor out the GCF now. The first step is to determine the GCF and then write it. Let's begin by looking at the numerical coefficients. We have 8, negative 36, and 4. The GCF for those numbers is 4. Next, we'll look at the variables. We have n to the fourth, n to the third, and n to the second. The lowest power of the variable is 2, so our GCF will have n to the second power. Next, we're going to divide each of our terms by the GCF of 4n squared. And then write the resulting terms inside of parentheses in our factored expression. 8n to the fourth divided by 4n squared gives us 2n squared. Negative 36n to the third divided by 4n squared gives us negative 9. We'll put a minus 9 in here. N. And finally, 4n squared divided by 4n squared leaves us 1. So we'll put a plus 1 here. And now we have our factored expression. 4n squared times parentheses 2n squared minus 9n plus 1. Let's move on to the next practice problem. Now we're going to factor the GCF out of the polynomial 10x to the fourth y to the third minus 5, x to the third, y to the fifth. Let's do that now. We'll start by determining the GCF of the terms in this polynomial. The numerical coefficients are 10 and negative 5. The GCF of those is 5. This polynomial has two variables, x and y. So for each variable, we'll determine the lowest power. We've got x to the fourth and x to the third. The lowest power of x would be x to the third. For the y's, we have y to the third and y to the fifth. So the lowest power of y is y to the third. Now we can divide each of these terms by our GCF and write the resulting terms in parentheses for our factored expression. Let's look at our first quotient here. 10 divided by 5 gives us 2. X to the fourth divided by x to the third gives us x. Y to the third divided by y to the third gives us 1. So we have 2 times x times 1. We don't really need to write the 1. We could just write 2x. Now for the second quotient, let's look at this. Negative 5 divided by 5 is negative 1. X to the third divided by x to the third is 1. Y to the fifth divided by y to the third is y squared. So we have negative 1 times y squared. All we really need to write for that is minus y squared. So our factored expression, with everything simplified, is 5x to the third y to the third times parentheses 2x minus y squared. Let's move on to the last practice problem. Our final polynomial is negative 9 a to the third minus 27 a squared plus 90 a. And just notice the first term in this polynomial is negative, so we should keep that in mind as we factor out the GCF. Our first step is to determine the GCF and write it down. So let's look at the numerical coefficients. We have negative 9, negative 27, and 90. And ordinarily we'd say the GCF is 9, but because our first term is negative, we're going to write negative 9. Next, let's look at the variable. We have a to the third, a squared, and a, the lowest power of the variable, is a to the first, or just a. Now that I have the GCF, let's divide each of the original terms by the GCF. And then we'll write the resulting terms in parentheses in our factored expression. Negative 9a to the third divided by negative 9a gives us positive a squared. Negative 27a squared divided by negative 9a gives us positive 3a. And finally, positive 90a divided by negative 9a gives us negative 10. And now we have our factored expression. Negative 9a times parentheses a squared plus 3a minus 10. That concludes our video lesson on factoring out the GCF.